Hello everyone, thank you for attending my presentation. My name is Ilham Qasse and I'll present the paper entitled iContractBot, a chatbot for smart contract specification and code generation. This work was done in collaboration with Shailesh, Mishra and Mohammad Hamdaqa. Smart contracts are computer programs that are deployed on blockchain platform and they are executed only if a predefined conditions are satisfied. The main features of a smart contract in blockchain is that they are immutable. This means that once the contract is deployed, it cannot be modified. Moreover, they are decentralized, which means there is no single machine that is controlling the smart contract. In fact, all the nodes in blockchain network stores the contract with exactly the same state. Furthermore, smart contracts enable blockchain technology adoption in many use cases, including healthcare, identity management, Internet of Things, etc. There are many blockchain platforms that support smart contract development, which are Ethereum, Hyperledger Fabric, Cardano, EOS, and many other platforms. However, smart contract development is challenging, especially to non-technical users such as stakeholders, as they cannot understand the code. This is further complicated by the fact there is many languages and platforms where each platform has its own terminology and syntax. To shed light on this challenge, this is a snapshot of smart contract code in two popular programming languages, Solidity and Composer. In this example, we are creating a contractual party patient for medical use case. Notice that the syntax and the terminology used to define the patient and its attributes are different. To define patient, we have used the terminology participant in Composer, while struct is used to define it in Ethereum. This shows that there is a need for the users to know and understand the smart contract code and the blockchain structure, which is complicated. One of the popular approaches used to address smart contract development challenges is model-driven engineering. Model-driven engineering is a software development methodology that focuses on creating and exploiting domain models. Following this approach, we have previously introduced iContractML, a domain-specific modeling language for smart contract modeling and development. In this framework, we have used this model to generate smart contracts artifacts for three platforms, which are Ethereum, Azure, and Hyperledger Composer. Using iContractML, it will be easier for the users to understand and generate artifacts without the need to learn the syntax and the infrastructure of each of the supported platforms. However, it's not interactive and it's not seamless, as it does not provide guidance on how to use the language. Moreover, the contract creators still need to learn the model construct. A promising solution to tackle this issue is using chatbot, where it can be utilized to facilitate non-technical users to use model-driven engineering tools and also to enhance usability and user experience while interacting with models. Hence, in this tool paper, we integrate the chatbot application with the model-driven based framework iContractML. Moreover, we introduce iContractBot, a goal-oriented chatbot application to allow users, whether technical or not technical, to develop their smart contract in a gradual and interactive manner. The main goal of this paper is to create a conversational agent for model specification, where we have the conversation with the smart contract developer as an input and model specification as the output. Any goal-oriented conversational framework requires an intent recognition component to understand the user's goal or objective. Hence, the first component we have in our system is intention detection, where the bots classify the end user's input into one of the predefined intents. To link natural language conversation and modeling specification, we need to map the detected user intent to the model specification of iContractML. In order to provide this link, there is a need to identify the principal entities of the model and represent it as a key structure for mapping it to the captured user intent. The next component is model validation. In this component, we are performing input sanitization at the chatbot level and output validation for the created model before any model transformation. This validation is done based on a predefined rules that will enable the chatbot to handle incomplete or inconsistent elements defined by the user. Once we have a valid model, we generate the code using model transformation component. This figure demonstrates the implementation of iContractBot and highlight the main components of the framework. We have the following components, which are ChatKit framework to detect the user intent, validation entities, modeling service, and extend to generate the smart contract artifacts. There are many chatbot frameworks available to build conversational bots and to detect intent, such as Google Dialogflow, IBM Watson Assistant, and ChatKit. ChatKit is an open source framework that supports integration with the previously mentioned platforms to capture user intent and to understand advanced natural language. Moreover, this framework empowers building platform-independent chatbots. Hence, in this paper, we have adopted the ChatKit framework to build the conversational bot and to detect the user intent. The user intent is detected based on a predefined set of expressions or set of training sentences. The modeling service component represents the linking of the user intention to the modeling specification of iContractML. We have identified the principal entities of the iContractML and represented as a key structure for mapping it to the capture user intent. The principal entities is a business process contract that manages the relationship between number of contractual parties, which participant. The contract defines those parties and gives them privilege that are stated as conditions of who, how, and when a predefined process, which is transaction, is executed in order to change the state of thing of value to the participant, which is an asset. Asset can be anything that has value, such as goods, services, properties, money, vehicles, or real estate. The state of these entities are stored in blockchain. Using iContractBot, we have created models and generated the deployment artifacts for a vehicle auction use case. In this use case, a smart contract is used to auction vehicles, where the vehicle is the key asset. There are two participants in this example, owner and bidder. The smart contract is created by the owner to auction his or her vehicle. The bidder can place bids on the vehicles that they are interested in. This is the DSL instance model generated for this use case. As you can see here, we have the main classes of iContractML, and we have mapped them to the user intent to create the auction vehicle use case. This is a video that shows the conversation used to create the vehicle auction use case. This is a sample of the generated code in Ethereum. As you can see here, we have the contract vehicle auction. We have two participants, which is the owner and bidder, the vehicle as the key asset, and we have the two function, which is place bid and withdraw. In conclusion, in this presentation, we started by explaining the need for more interactive and easier way to enable the non-technical people from composing and creating smart contracts. Hence, we have proposed the use of chatbots in order to generate smart contract artifacts. Moreover, we have presented the architecture and components for our model-based chatbot for smart contract, and we have showed by example how it can be used to create smart contract for vehicle auction use case. In this tool paper, we present the framework and the components. However, we have omitted many of the technical details that will be highlighted in a subsequent work that is currently under consideration for publication. That's the end of my presentation. Thank you for attending.